Thank you for joining me for the beginning of Chapter 8. This is our last chapter for Algebra 2. So Chapter 8 in general is about rational expressions, okay? So essentially polynomials where you start dividing them, creating fractions out of them. Before we dive into that piece, we're going to start with something called inverse variation. Now this is something you've seen before, probably in chemistry and stuff like that, but now we're going to give it a mathematical name and call it inverse variation. Now, there's two types of variation, all right? One you've already worked with a lot throughout math. That's called direct variation. That's this side over here, okay? So direct variation takes the form y equals kx. So essentially, what does that mean? Well, that should look familiar to you. All that is a linear equation that goes through the origin, okay, that has a y-intercept of 0. Now, what is inverse variation? Well, inverse variation is the other side of things. So instead of our x multiplying our k, it's dividing our k. Well, what is k? Because that's something new to you also. K is called a constant of variation, all right? Now, in linear terms, that would be the slope. But now in variation language, we're talking about constant of variation. All right. The only rule that it has is the constant of variation can't be 0 because otherwise you have nothing happening. You're just going to have y equals 0, and that's going to be a really boring equation. So the first skill in talking about these is determining if data sets are direct, inverse, or sometimes neither. All right, so that's going to be our first skill. Just if I give you a table of values, can you tell me what kind they came from? Okay, is it direct or is it inverse? Well, the way to determine that is just start plugging the values in. All right, you kind of have to just check to see which one works. So, what do I mean by that? Well, determine each type of variation and give the equation. Well, if it were direct, okay, if it were direct, it would follow that pattern. So what I'm going to do is I'm going to start plugging in some of those values from the table, because if I get a consistent k for each one of them, then that means that it would be direct, because that is the equation of a direct variation. So what do I mean by that? Well, I'm going to plug in 8 and 0.2. Well, how do I find k? Well, 8 divided by 0.2 is going to give me 40. Let's try the next point. All right, because if this is also 40, then it means it's a potential candidate for a direct variation. So how do I find k? We'll divide by 0.5. 20 divided by 0.5 does in fact give me 40. Let's try the next one. Plug in 40 and 1. Divide the 1. Obviously, you get 40. Then in this one, 60 equals k times 1.5. Divide by the 1.5, and you do get 40. So by plugging each point into the direct variation equation, I get a consistent k value. So that shows me that this data does create a direct variation, and its k is 40. So the equation is going to be y equals 40x. All right? So that's what it looks like to determine this. Well, you may be wondering, is there another way to tell? Well, if you look at the data, if you were to make a scatter plot of the data, you see the data fits a perfect line. All right? That's what these direct variations look like. They are perfect lines. All right, now what about the other one? So let's see that second data table. Let's see if that's direct. So if it's direct, then y is going to equal k times x. So we're going to plug in values to see if it fits that model. Are we getting a consistent k value for each pair? Well, let's plug in y. So 15 and k times 2. So if I solve for k is going to be 7.5. All right. Let's try the next one. 7.5 equals k, then my x is 4. Well, this time, I divide off that 4. I get a k of 1.875. So when I plugged it into the direct variation equation, I'm getting different k values for every point. So what that means is this cannot possibly be a direct variation. All right, that's what this is telling me. Well, if it's not direct, let's try the other one. So if it's inverse, it's going to follow that pattern. All right, so let's see if this pattern makes it work better. So I'm going to plug 15 and 2 into that pattern. When I solve for k, so I multiply the 2 over, and I get my k equals 30. Let's see if that works for the next one. So when y is 7.5, my x is 4. Multiply the 4 over, I get k equals 30 again. Let's try when y is 3, x is 10. Multiply the 10 over, you'll see k is 30. When y is 2, x is 15. Multiply the 15 over, and you get k equals 30. That constant of variation is consistent for every one of them. So what that means is this is an inverse relationship, and the equation, the equation, we found that k is 30. Okay, so again, that's all it takes. Just plug it in to both equations, see which one gives you a consistent k value, a consistent constant of variation, and that's going to be the type it is. Now, I know this can be a little bit of a struggle, okay? So I want to go over a couple more examples just to make sure you're feeling comfortable with this process, all right? So again, you just kind of have to pick one and roll with it. All right. Now, as you do examples, maybe you'll start recognizing which it is before you plug it in so you can pick the right one right away, like it did in the first example. But again, like the second example, if you pick the one that doesn't work, try the other one. All right. So let's see if this is direct. All right. So I'm going to plug in 1.5 and -1. So divide that -1. So my k is going to be -1.5. Let's try the next pair of x and y. So now divide by 1. I still have the same k, but let's try that last point. -3 and 2. When I divide that 2 off, so I did. I got a consistent k value for every one of these. So what that's telling me is that there is in fact a direct variation. And the equation is when I go back and I plug in that value for k. That's the equation that models this data. If you plug any x into that equation, it'll give you the proper y value from that table. All right, and our next one. So again, I just usually start with direct, see if it works. If it doesn't, then I move on to inverse. So let's try the first one. Y is -10 and x is 40. When I divide by 40, I get -10 divided by 40, I get negative 0.25. All right, let's try the next one. Negative 5 equals k times 20. So negative 5 divided by 20 also gives me that. And 2.5 and negative 10. So this one worked again as direct. Okay, so what this means, I got a consistent k value for every one of those. So that means my equation is when I plug that negative 0.25 back in for k. All right, so let's see what a word problem looks like using these. So your math class has decided to pick up litter each weekend in a local park. Each week there's approximately the same amount of litter. The table shows the number of students who worked each of the first 4 weeks of the project and the time needed for the pickup. Determine if this is a direct or inverse relation, and what equation models it. So that's essentially asking the same thing we've been doing. All right. So again, let's start by seeing if it's direct. If it's not, then we'll check to see if it's inverse. So let's plug in the first x and y. So 24 equals k times 10. Divide the 10 off. Your k is going to equal 2.4. Let's plug in the next x and y. And if you see I'm using x and y still, so technically they're using n and t, but as long as you note what you're using, then this consistency I think will help you see what I'm doing so you feel more comfortable with it. But again, technically they're using n's and t's. But anyway, so 20 divided by 12 gives me 1.6 repeating. So I got different k values. So what that's communicating to me is that this can't be a direct variation, because if it were direct, I should be getting a consistent k value. So what that means is we need to try the inverse equation now. All right, so inverse looks like this. Inverse is when you're dividing by the x instead of multiplying by it. Let's see if this ends up working better. All right, so I plug in my values. When I multiply that 10 over, I get a k of 240. Let's try the next one, 20 and 12. Multiply the 12 over, you get a k of 240. How about the 16 with the 15? Multiply the 15 over. Once again, you get k of 240. And the 7.5 with the 32. So 7.5 and multiply that 32 over. So by using the inverse relationship, by using that formula, I got a consistent k value for every single point. So what that's telling me, this is in fact inverse, and the equation that models it looks like this. All right. So again, I don't think it's that difficult. All you have to do is remember that direct is y equals k times x, inverse y equals k divided by x, and then just plug in the points until you find which one gives you consistency in those k values. All right, now, How about that next piece? How many students should there be to complete the project in at most 30 minutes? All right, so what that means. So here we want the time, we want our time to be less than 30. So we're letting x be the number of students, and we want our value to be less than 30. We want to spend less than half an hour picking up the litter each day. All right? Well, how can I solve this equation? The x is in the denominator. We're not really used to seeing this. So what I would do is I'd multiply the x up like that. Okay, and technically at most, I should be including the or equal to. So once you multiply the 30 up, or the x up, now I'm going to divide by 30. So if I divide by 30, what that's telling me is if I want to spend less than half an hour, I should have at least 8 students with me for this project. All right, let's move on to the last slide. So here, writing inverse equation or writing variation equations. So when they tell you that x and y vary inversely or x and y vary directly, really they're giving you which format to use. All right, so if it's direct, you set up this kind of format. If it's inverse, you set up this kind of format. And again, the way that I remember is direct means k is being multiplied. Inverse means k is being divided by the variable, okay? To me, that's the best way to remember, because tomorrow we're going to dive into combination variations, where that's going to become even more important for us. So, suppose x and y vary inversely. Well, inversely tells me I have this set up. All right, so the first step is picking the right equation, okay? Inverse means you're dividing by the x. And then they tell you x is 4 when y is 12. All right, well, what does that do for me? Well, what it's doing is it's giving me an x and y, just like we got from the data table. So now what that's doing for me is I'm actually able to find k. When I multiply that 4 over, it's telling me that my k is going to be 48. And why do I need k? Well, I need k because in order to actually write the equation, I need the k to plug back in to that first setup and give me my true equation. All right? The equation, that relationship is y equals 48 divided by x. Now, what is y when x is 10? Well, that's easy. Now that I have the equation, I can just plug it in. So that's what the second piece is. So if you can learn these steps, tomorrow is going to be super simple for you. So let's take a look at our next one. So again, I'm seeing inverse, which tells me I'm dividing by the x. Inverse always means you're dividing by whatever the variable is. And they're telling me that when y is -5, x is 2. So when I multiply that 2 up, I'm getting my k is -10. So now that I know what k is, I want to actually put that into my equation so I can have my legitimate equation, that y equals -10 over x. Just like what we were doing before, the legitimate equation is always in the terms of x and y. Okay? You find what k is in order to write the equation. And now the second piece, what is y when x is 4? Well, again, all you have to do at that point is plug in the 4 Negative 10 divided by 4 gives you a negative 2.5 for that answer. Now, for this one, notice now they're varying directly. Directly means you're multiplying the constant variation by the variable. All right? So you have to know the difference between the two. That's going to be the key to this. So y is negative 8 when x is negative 4. Well, divide off that negative 4. You'll get that k is 2. So my actual equation is y equals 2x. Then for the last piece, what is y when x is 12? All you have to do is plug it in, and y is going to be 24. All right, so that's actually it for the notes today. So hopefully not too difficult, but there is some good stuff to talk about. So can you please make sure to write your summary here for me, and then come back to class prepared to work on your practice work.